Here we'll be converting decimal 48 into binary. So I'm going to start by finding 2 to the power of 5. That will equal 32, which is the lowest base I can use for this 48. 2 to the power of 6 would be 64, which is much too big. We only need one of those. And then next we'll go 2 to the power of 4, which is 16. And those together actually would equal 48. And so now we can take these and convert it into our binary code. So for every digit other than this 2 to the power of 5 and 2 to the power of 4, we're going to just fill in 0. So 2 to the power of 0, 0. 2 to the power of 1, 2, 3. Then we have our 4 and 5, and 6 and 7. And this is our answer in binary code. Here I'll be converting binary 10010110 into hexadecimal. But first we're going to have to put binary into decimal. So I'm going to start by listing the bases, 2 to the power of blank. So this is 2 to the power of 0, which we have 0. 2 to the power of 1, and then 2 to the power of 2. 2 to the power of 3, there's none. 2 to the power of 4, and then 5, there's none. 6, there's none, and we have 1, 4, 7. So 2 to the power of 7 plus 2 to the power of 4 plus 2 to the power of 2 plus 2 to the power of 1 equals 150. So now that we have our decimal, we're going to convert it into hexadecimal. So we're going to start out with 16 to the power of 1. The 16 to the power of 2 is just too big to fit into 150. So 16 to the power of 1 times 9 is 144. And then 6 times 16 to the power of 0 is 6. And those equal 150. So we'll take our 9 and our 6, and it'll be 9, 6, and a base 16. Now I'll be converting hexadecimal 78 into binary. But first we'll have to convert hexadecimal, of course, into decimal. So for our first digit, that's 16 to the power of 0. We'll times that by the 8. Our second digit will be 16 to the power of 1. And that's by 7. And this comes out to 120. Now we have our decimal, and we can convert it into binary. First, I'm going to start out with 2 to the power of 6, which is 64, plus 2 to the power of 5. We'll just go right over to the next smallest one, usually works. That'll be 32. So this is 96 put together. 2 to the power of 4, 16. Then for the next one, we'll do 2 to the power of 3, which is 8. So 96 plus 24 comes out to 120. So now we have our 2 to the power of n bases, and we can write our binary code. So for 2, we start out at 2 to the power of 0. We have none of those. 2 to the power of 1, 2 to the power of 2, and then 2 to the power of 3, we have 1. 2 to the power of 4, we have 1. 2 to the power of 5, 6, and then 7, we have none. And that is our binary code. So now I'll be converting decimal 644 to hexadecimal. So I'm going to start with 16 squared, and that goes into 644 about 2 times. It gives us 512. So we have 132 left. 132 divided by 16 simplified 8. Take 16 to the power of 1 times 8. 128. Then we only have 4 left. So we'll just do 4 times 16 to the power of 0 to get 4. So equal 644. And we'll take these numbers, of course. Do 284 at a base 16. Here I'll be converting hexadecimal 211 or 211 to decimal. So I'm going to start on this side. And that first base will be 16 to the power of 0, which we have 1 of, plus 16 to the power of 1, which we only have 1 again. And then we'll do 16 to the power of 2, and here we have 2 of those. And this comes out to 529, and that's our answer in decimal. Now I will be converting decimal 231 into octal. So first I'm going to find the highest base that I can, or not base, but highest exponent that I can take 8 to get the closest to 231, which is just squared in this time. And 8 squared is 64, and 231, only 3 64s will fit into that, which is 192. I'm going to go plus 8 to the power of 1, which is just 8. And for we have 39 left from 192 out of 231. So we'll grab 4 of those for 32. And then at that point, we just have 7 left that we need. We have 8 to the power of 0. 7 of those plus 7. So 192 plus 32 should equal 231. We just take these numbers, and our answer is 347 at base 8. Here I'll be converting octal 272 to decimal. So our base for octal is going to be 8. So starting here, it'll be 8 to the power of 0 times 2 plus 8 to the power of 1 times 7 plus 8 to the power of 2 times this 2 here. And this comes out to 186. And that's our answer in decimal. Here I'll be converting hexadecimal B5 into octal. So for hexadecimal, our base is going to be 16. So for this first one, we're going to do 16 to the power of 0 times that 5. And then for the next, for B, do 16 to the power of 1. And B, converting it into decimal, is going to be 11. Oh yeah, and I forgot to mention, we're converting this into decimal before we go into octal. So this comes out to 181, and now we can start converting 181 decimal into octal. So I'm going to start out with 8 squared, 64. We're going to times that by 2, so that'll be 128 plus 8 to the power of 1. And we can do that by 6. That'll be 48. And from there, we only have 5 more we need. So we'll just do 5 times 8 to the power of 0. That'll be 5. So 128 plus 148, or sorry, 128 plus 48 plus 5 will equal our answer 181. So we'll take these digits, and we'll go 2, 6, and 5 at the base of 8. And that'll be our answer.